Sorry guys, I was not able to continue the previous video due to the marker problem. So let's start development of surfaces. We have already discussed why it is important and what it means. Now we will discuss how many ways by which we can develop the surface for any solid. There are two methods. First one is parallel line method and second one is radial line method. Parallel line method is used for any prism, like the prism may be square prism, pentagonal prism, hexagonal prism. Parallel line method is used for any prism or a cylinder. And second one, that is radial line method. Radial line method is used for any pyramid and cone. What is the difference between prism and pyramid? We already know. One in other way we can also say parallel line method is used when the axis of the solid, suppose this is a solid, when the axis of the solid is parallel to its side faces, then we will use parallel line method. And when there is a second example, second solid, this is a square pyramid, this was a square prism and this is a square pyramid. In case of a square pyramid, the axis is not parallel to its side faces, and also here in case of pyramid there is only one base and there is apex, and in case of prism there are two parallel faces, one bottom face, and as the bottom face is there, similar face is on upper face. When bottom face and upper face both are parallel, then we will use parallel line method. And when there are only one bottom face and upper face is not similar to the bottom face and there is apex, then we will use radial line method. One by one you will come to know what is the difference. Let's take an example and go to our first question. Our first question is develop a square pyramid. Development of a square prism. Development of a square prism means first of all we have to consider which type of solid we have. So if we are talking about development of square prism, so we must know what is a square prism and what it looked like. So I have one square prism. See why it is called square prism, as the bottom face is of a square shape and upper face is also of a square face, and bottom face and upper face both are parallel. That's why it is called a square prism. And now we have to develop the surface for this particular solid. What we will do, first of all we have to draw its front view and top view. How we will draw its front view and top view we have already discussed in case of projection of solid, so no need to tell you how we will draw, you know it better. So what I said if you have to draw the development of a square prism or any solid, first of all what you have to do, first of all you draw their first front view and top view. Here development of a square prism means we have to develop the surface of a square prism. So first of all what I did, we draw its a top view and its a front view. This will look like this, its front view and its top view, this. And there are what it is 1A, it means suppose we are considering the upper corners A, B, C, D and bottom corners 1, 2, 3, 4. 1, 2, 3, 4. This is what we have mentioned here, 1, 2, 3, 4. This is bottom corner of the square and upper corner is A, B, C, D. This is what I have mentioned here, A, B, C, D. What we call, we are considering the upper faces A, B, C, D and we are considering bottom faces 1, 2, 3, 4. This is what I have clearly mentioned here and I think you know it very well. So next step what we have to do, already we have mentioned parallel line method for any prism. Here we have a prism, so it is an example of parallel line method. We will apply here parallel line method. What we have to do in case of parallel line method, just this side, this height is given, this side is also will be given in question. Suppose this is 25 mm side and height is suppose 60 mm. So we will draw two parallel lines. One is from upper side, from here to here randomly. Length may be whatever you want to take, you can take. And one second line we will draw this parallel line. What we'll do next, what it given, the side is given of 25 mm. We will take the compass and consider it 1 to 2 like 25 mm. Why 25 mm? Because it is given side of the prism is 25 mm, and that 25 mm we will cut after giving some space from this XY line. After giving some space, we will take suppose first point here and 25, second point 25, third 25, fourth 25, 1 to 8, 1 to 2, 1 to 2 25, 2 to 3, 2 to 3, 2 to 3 25, 3 to 4, 3 to 4 25, 4 to 1, 4 to 1 25. We have already discussed the bottom faces we are considering 1, 2, 3, 4. This is what 1, 2, 3, 4, and once again overlapping, due to overlapping once again this one will come. And of our faces we are considering A, B, C, D. Here it is A, B, C, D. Like A to B, that is also 25, A to B 25, B to C 25, C to D 25, D to A 25. Or we can directly place a parallel line from 2 to upward, 3 upward, 4 to upward, 1 to upward, and the final structure we will have like this. So what we did, we have developed the surface, this much area. If we will have this much of area, this type of rectangular area, we can make this solid, and that solid is a square prism. Let's take from here. This was initially, this is 25, this is 25, this is 25, this is 25, and height is 60 mm. 25, 25, 25, 25, 65 mm. Means 4 faces are here. One face, one square face, one rectangular face, first one, second rectangular face, second one, third rectangular face, third one, and fourth one rectangular faces. And now if I will open it up, it will look like similar to this one. There are size difference because this is comparatively bigger one, but it will look like same. First, second, third, and this one is fourth. So what we did, we have already developed the surface of a square prism. I think you will understand it. And now take another example. Suppose now if we have to develop the surface for pentagonal prism. In that case, what will happen? Now the second example is pentagonal prism. It means now you are aware there will be pentagonal bottom face and upper pentagonal faces. So what we will do, we will draw pentagon 1, 2. Here 1, 2, 3, 4, 5 faces will be. So what we will do, we will draw line, and whatever the height may be, see, suppose this type of structure will, if there will be pentagonal prism, the front view will be similar to this and the top will be something like this. What we will do, we will cut here, there are 4 sides, so we cut 4 times, 1, 2, 3, 4. In case of pentagonal prism, there are 5 sides, 1, 2, 3, 4 and 5 sides. So what we will do, we will take an initial point and cut 1, 2, 3, 4, 5. If this solid will pentagonal prism, in that case we will have 5 rectangular faces. First face, second face, third, fourth, fifth. 1, 2, 3, 4, 5 and once again 1. If there will be hexagonal prism, in that case we will cut it 6 times, because in case of hexagonal there will be 6 faces. I think you are getting my point what I am saying. Okay, let's take the next example. So this is what, if we have to develop the surface of prism, square prism. In case of square prism there are 4 faces. In case of pentagonal prism, this will be one additional side we will add. In case of hexagonal prism, one additional side, means there will be 6 sides. I think it's clearly understood. Next is development of a cylinder. This is very easy. Suppose what I said, First of all, draw front view and top view of a solid of which you have to develop the surface. In second case, development of cylinder. In case of cylinder, it will be given there is a cylinder of this much of radius or this much of diameter and their axis length or their height is this much. Suppose we are considering the cylinder radius of 50 mm and height is suppose radius of 25 mm and height is 100 mm. So we will draw radius of 25 mm in case of cylinder. Top view, what we will find? We will find top view a circular shape, and in case of front view of a solid, what we will get? We will get this type of structure, a rectangular surface. So first of all, we will draw top view and front view of a cylinder, and after that I know what we have to do. Initially I have said if this solid is cut and open it up, this is what? This is nothing but the developed surface of cylinder, and this area we have to find. And we already know if we will cut the solid, if we will cut the cylinder and open it up, this will be equal to 2 pi r, and I think no need to say, you know it very well. So that is what I have done it here. So take some gap from this line to this line to make it separate. This is suppose our initial point, and this is also an example of parallel line method. Here it is a cylinder, and this is example of parallel line method. What we will do, we will draw front view and top view and draw a parallel line method roughly. We'll draw a parallel line method roughly. Take an initial point here and equal to 2 pi r. 2 pi r, r given here 25 mm, 2 pi into r, whatever it comes, take compass, cut a arc, and from here this point draw this particular area we will have, and if we are going to fold it, we will got this cylinder. We had to develop the surface of a cylinder of radius 25 mm, height 100 mm, cut it, open it. Similar to this area, we have the area. We have already developed the surface, developed the area for cylinder. I think this is also no anything tough to understand. I think this is also very easy task. Now take third example. And this third and fourth is example of radial line method for any pyramid. So in case of third question, we have taken pyramid. Consider a square pyramid. Cone. In fourth question, we have taken the example of cone. So third question and fourth question is the example of radial line method. We will easily find out what is the difference between this parallel line method. This is the example of parallel line method. This is the example of parallel line method. What we done here and what we will do here, we will be very easy to find out what is the difference between them. So in case of third question, here we have to develop the surface of a pyramid. Consider a square pyramid. Here it is the practical example you can take. This is what? This is of square shape, and all the faces are going upward. All the faces, side faces are going upward and meeting at a particular point, what you call apex or vertex. So this is nothing, this is a square pyramid. So what we said initially, if you have to develop the surface of any solid, first of all draw the front view and top view of that particular solid. Here we have solid a square pyramid. So in case of a square pyramid, if you will draw the top view of the pyramid, you will get the surface like this. You will get this type of shape. And if you will draw the front view, look, front view, this face you will get. In case of front view, you will find out this. So this is the front view and this is the top view of a square pyramid. Square pyramid. This is the top view and this is the front view. And next step, final, we have to do what we have to do. We have to develop the surface of this pyramid. So after taking some distance from here, Suppose this is point O, we have taken here point O. We can, if you want, you can draw a line up to here and you can take point here. This is initial point O and O. And take a compass and take the length equal to this much, or you can say equal to the slant height or slant length. This is the axis length, this is the axis length, and this is what we have slant as a height of slant has or length of slant side. So we will take compass. Suppose this is needle point and this is pencil point. Needle point out up here O and take the radius equal to the length of the slant height and draw a radius like this, radial. And you don't know up to which point we have to take, so you can take the needle point here, take this radius, point O to 1, this will be equal to this slant length. I think you are getting my point. Point O to 1 we have to take radius, and this O to A will be equal to this point, this slant length, or you can say slant height. Take and roughly draw a curve. Why it is called radial method? Because here in this case we are taking radius and equal to that radius we are drawing a line. So this is what we have drawn roughly. And after that what we will do, here in case of square pyramid there are 4 square face. This is 1, this is 2, this is third one, and this one is fourth one. 1 to 2, 2 to 3, 3 to 4, 4 to 1. Take the initial point first point here, cut, take the arc 1 to 2 first arc, 2 to 3 second arc, 3 to 4 next arc, 4 to 1 next arc. How many faces is here? There are 4 faces. Look, first face, second face, and third face, and fourth face. This is similar to first face, second face, third face, and fourth face. If this is the solid and we are cutting and opening it up, similar to this structure, similar to this shape or area we have find out. I think you are getting my point. So once again I am going to discuss what we have to do. In case of development of pyramid, what we have solid, the square pyramid. In case of square pyramid, first of all draw its a top view and its a front view. After taking some gap, this point you can take anywhere. Suppose this is our O point. This is our O point, this point, and equal to this slant height. Either you can mark this one or you can mark this one. This will be equal. And equal to this length, you develop a arc. This arc you can take upward here, roughly. After that, taking the side 1 to 2, suppose it is 25 mm side, 25, cut on that arc, 25 at the descent of 25, second, third, fourth. Mark it, name it 1 to 2, 1, 2, 2 to 3, 2 to 3, 3 to 4, 3 to 4, 4 to 1, 4 to 1. This was similar to this. And now if you will fold it, you will get our solid, that is square pyramid. Now take the next example, and that is cone. This is also example of radial line method. See here, any pyramid, we have already taken the example of a square pyramid, and one more solid is here, cone. This will be also drawn by the radial line method. Here what we have solid, we have this cone. Cone means there will be a base, circular base, and all the side will be at point this. This is our cone. And if this cone we will cut from its side, and if we will open it up, this type of structure we will find, and this is what we have to draw. Let's see how we will complete it and how we will draw it on the sheet. So first of all, what we have to do, we have to do here, we have solid cone. First of all, what we have to do, we have to draw top view and front view of that particular solid which we have to draw, which we have to develop. So here in case of fourth question, we have to develop the surface for a cone. So we will draw the top view. This is the top view of cone and this is the front view of cone. And suppose this is given 25 mm radius and the axis length is given suppose 50 mm. Accordingly, we will draw the top view and front view. And what we will do, we have to find out this type of area. How we will find out? Let's see. After taking some distance, this is point O, this is point O. You can draw a line after taking a suitable distance. It should not be much closer and it should not be much far away. Taking a suitable distance from this particular point. O, you can take this O point, and what we have similar to this, here what we did, O to, after taking this much of slant and we have roughly drawn. In case of this cone, we will similarly, we will take the slant length or slant height. This is its slant length or slant height. We will take a compass. We will put the needle point at point O and extend it up to equal to the length of this slant height. Extend it and draw it. And we don't know up to where, either it will be up to here or it will be up to here or we will be up to here, we don't know. Simply what we have to do, simply taking radius equal to this much and draw. And we must know how much this theta will be. So to find out this theta, we have a formula. Theta is equal to 2 pi r divided by r, or we can say theta is equal to 2 pi yani ki 360 degree into r divided by capital R, where this small r is the radius of base circle, this is small r, and where is this is capital R. This is capital R, this slant, this is capital R and this is small r. Put and you will find out some value. Suppose 120 degree or 100 degree, whatever it comes, equal to that, this is theta. Suppose you are getting 110 degree. After 110 degree, you just close it. Now you have developed the surface for this